Hello, this is Mr. Miller. I hope you're having a wonderful day. It's time for video number 16 on literal equations and more coins. Let's go. This first slide contains some literal equations. Literal equations are equations that have more than one variable, and our job is to solve for one of the variables. They'll tell us which one to solve for. At first, this seems really strange, but once you get the hang of it, it's actually easy because we don't even need a calculator. We're not doing any arithmetic. So let's take a look at the very first problem. This first problem says P equals 2 times L plus 2 times W. This is actually a formula for the perimeter of a rectangle. We want to solve for the variable W, which means we want to get it by itself. So the first thing we want to deal with is this term 2L. I want to get rid of the 2L. Then I'm going to deal with the 2. So I'm going to subtract 2L from both sides. We're going to use our basic moves to solve these. So whatever I do to one side of the equation, I do to the other. On the left, I have P minus 2L. I can't combine those, so I just write it as P minus 2L. That's why this is easy. I didn't have to do any arithmetic. Then equals 2 times W. All right, very good. This is a little bit better. I almost have W by itself, but I have to do something about this 2 that's multiplying W. Well, the way we undo multiplying by 2 is divide by 2. So we're going to divide all of both sides by 2. So the whole left side by 2, the whole right side by 2. The left is actually done. There's not much I can do with that. So it's P minus 2L over 2. And on the right side, 2 divided by 2 is 1. That's why that cancels. And we're just left with 1W or W. There it is. We solved this formula for W. If you told me P and L, we could substitute into here and find out what W is. Okay, over here, this should be a familiar equation from algebra. We're going to see more of it later, but right now, we just care about solving for one of the variables. We're going to solve for M. Okay, get M by itself. Same thing as the previous equation. I got a term here I don't want. I don't want the B. So I'm going to subtract B from both sides. Minus B, minus B. On the left, y minus b. You may wonder, what is that? Well, it's just y minus b. And on the other side, m times x. Because b minus b is 0. Okay, so now, again, I almost have m by itself. I have m times x. So I'm going to divide both sides by x. And on the left side, I have y minus b over x. X divided by x, as long as it's not 0, we're assuming it's not 0, x divided by x is 1. Any number divided by itself is 1. So I'm just left with m. And that's an x there. Okay, done. We solved it for m. This last one has 5 letters. Okay, we want to solve for y. All right, this ax has got to go. So we subtract it. Subtract ax from both sides. On the left, we'll have b times y. And on the right, we just have c minus ax. There's nothing to combine. It's just c minus ax. All right, well, there's one thing keeping us from having y by itself. We have b times y. And so we're going to divide by b. Okay, so b divided by b is 1. So we get y equals c minus a times x over b. We're doing the same things we did to solve equations with numbers, except here we have variables, and often we can't combine them. All right, let's look at some other examples. These formulas all come from geometry. This first one actually, a equals 2 pi r. We want to solve for r. So if we divide both sides by 2 pi, we can do that. So divide this by 2 pi, and divide this by 2 pi. Okay, so the reason why we divide by 2 pi is because we're multiplying by 2 pi. So a divided by 2 pi is just a divided by 2 pi. On the right side, the 2's cancel. Pi is just a number like 2. Pi divided by pi is 1. So both of those cancel. We were multiplying by 2 pi. And if we divide by 2 pi, it's just 1. And we get r equals a over 2 pi. This formula over here is for the volume of a cylinder. And we want to solve for h. So h, h is right there actually. So we want to solve for h. We see that h is being multiplied by pi r squared. So we're going to divide both sides by pi r squared. So volume equals pi r squared h. We don't want the pi r squared, so divide by it. By that whole side by pi r squared. On the left, we're stuck with what you see. V equals pi r squared. But on the right, pi divided by pi is 1. R squared divided by r squared is 1. We're just left with h. And we did it. H is by itself. One last one here. This is actually a formula for the area of a triangle. And we want to solve for h. A couple ways we could do this. I don't like this 2 here very much. So I'm going to multiply through everything by 2 to cancel it. So on the left, we would get 2a. And on the right, we get bh over 2 times 2. So I multiply both sides by 2, and that one cancels. And now I have an equation without fractions. 2a equals b times h. All right, I'm almost there. We want to solve for b. I was lying earlier. It's b we want to solve for. So I don't know what I was thinking about. This is the one we want to solve for, b. Okay, well, we can do that. We can divide by h. So 2a divided by h equals, well, the h's cancel, b. And that's our formula. 2a divided by h. Okay, well, we got one more coin problem. Let's take a look at this last problem. All right, so this is like the challenge problem from the last video. I'm going to get more into how to solve it. A piggy bank contains 700 quarters and dimes. That means the total number of coins is 700. If the value of the collection is 134.50, how many coins are quarters? All right, so we're going to try to solve this problem in terms of the quarters. So the first question is, could there be 250 quarters in the piggy bank? Well, if we know that there are 250 quarters, that tells us how many dimes there are. So if there are 250 quarters, 700 minus 250 are the number of dimes. So 700 minus 250 is 450, and that's how many dimes there are. And now we can figure out the value. So 0.25 times the number of quarters plus 0.10 times the number of dimes, which we figured out to be 450. Let's see what that equals. It equals 134.50. We're done. So let me grab my calculator. 450. Okay, I come up with $107.50. So 107.50. That's a little low. So that means there must be more quarters and fewer dimes. That would make the value larger. Okay, let's see if we can kind of trace our steps and write an equation. We want to write it in terms of Q, the number of quarters. So if I look at what my work here, the number of quarters appeared there, and it kind of appeared here, but not by itself. This was 700 minus the number of quarters. So the number of quarters is Q. The number of dimes is 700 minus Q. So let me write that again here. Q equals the number of quarters. And 700 minus Q equals the number of dimes. So let's write our equation. So we get that 0.25 Q plus, it'd be 0.10 times 700 minus Q is supposed to equal 134.50. Okay, we can distribute and solve. We get 0.25q plus 0.1 times 700 is 70 minus 0.10q equals 134.5. And if we combine like terms, we get 0.15q plus 70 equals 134.5. And I can backtrack. Right, when I do that, I get Q equals 430, which is kind of what I expected. I knew that our previous amount was too small, so at least we know that we should have gotten more quarters, and we did. If we wanted the number of dimes, for this problem, we just subtract it from 700. So that was the secret to the challenge problem. We got to express the number of dimes in terms of the number of quarters in this problem. So if you can, it's kind of complicated. If you can work out a guess, though, and see where the number of quarters appeared in the guess, you can write an equation. It just takes a little practice. All right, here we go. So a bunch of new stuff. This is getting challenging. So for the first part of your journal assignment, solve for the variable. Get that variable by itself. And then here's another problem for you. We have a jar of coins has 450 dimes and nickels. Remember, 450 is the total number of coins. And the value is $34. So figure out if there could be 200 dimes in the jar. So if there are 200 dimes, you should ask how many nickels are there, and then you can see if this guess is correct. Then let's write an equation for the number of dimes and solve it. And let me see, we've been practicing this a little bit. Let's see if you can do it. If not, that's okay, give it a try, and we'll do it in class. See you next time.